I shall continue with the story of the band structure. In the last video, I talked about how when atoms are close together, the energy level of each atom, or the energy levels among the atoms, become split into many levels that are very close together. And I also talked about how when you have atoms so close together, because of the wave nature of electrons, it is possible, even if there is this potential barrier between the electrons, which basically means that the nucleus of each atom would attract the electron too strongly for the electron normally to be able to go over to the other atom, but because of the wave nature of the electrons, can actually tunnel through to another atom. So in principle, whether or not there is this potential barrier, right, meaning that if an electron is high up in energy level where it is above this barrier, in fact, so that it can easily just move over to the next atom. So whether or not it is below the barrier or above the barrier, in principle, it can always, there's always a chance that it can hop over to the other atom, whether it's by just smoothly, easily traveling there, or by tunneling through the barrier. So what I'm going to do now is to look at this question about conductor and insulator. Now we know that there are things that can conduct electricity, like copper, metals. And we also know that many things don't conduct electricity, like plastic or wood. These are insulators. Now, according to my description here about the band structure, about the electrons, and about the tunneling and potential barriers and so on, what I seem to be suggesting is that as long as the atoms are close together, it is possible for electrons to just go from atom to atom because of the wave property. So does this not mean that all solids can conduct electricity? I mean, after all, electron can even tunnel through the potential barrier, right? So what's to stop the electron from just going from atom to atom? So that should mean that all solids can conduct electricity because of this wave property of the electron. Now, it is a bit tricky to understand why, given this wave picture, it's a bit tricky to understand why then there are such things as insulator in this world. And I would only be able to give a very brief and maybe not very helpful answer to this question. But I will also give a simple rule of thumb, which help us to tell when a material, in terms of the band structure, to help us to tell when a solid can conduct or not. Now let me write down this rule first, and I'll explain as far as possible. Let me start by saying that A solid is an a solid okay a solid is an insulator if all the occupied bands are full. Okay, if you're seeing this for the first time, it's going to look quite abstract. So let me try and explain what this means. Now, to do that, I need to go back to the atom. Remember that for the single atom, it has a number of different energy levels, each level corresponding roughly to an orbit in the atom. And each orbit, as I've described in the previous one or two videos, each orbit can only take up to a certain number of electrons. It cannot take more than that number. If, for example, the first orbit can take 2 electrons at most, next orbit can take up to 8, and so on. Now, and I think we also understand that not all the orbits will be full. It just depends on how many electrons there are. For example, the hydrogen atom, the first orbit has 1 electron, and the other orbits have no electrons because there's only 1 electron in the hydrogen atom. So for other atoms, for example, there would be a certain number of atoms, electrons in each atom, and they would just fill up the level until a certain level. Right? There will be no electrons above that. So if you look at hydrogen, for example, if let's say I have the hydrogen atom and there are a number of energy levels. Now the hydrogen atom only has 1 electron, so it will fill up just the ground, the lowest level. But this level, we say that this level is not full because we know that the lowest level can take up to 2 electrons. Okay, but in helium has 2 electrons and it will occupy the lowest level. So in the case of helium, the lowest level is full because you can't have more than 2 electrons in the lowest level. In lithium atom, lithium has 1, 2, 3 levels. Lithium has 3 electrons. So 2 of the electrons will go to the lowest level, 1 electron will go to the next level up. Now this level can have up to 8 electrons. So this level is not full. Okay, then if you go to beryllium, you have another electron, and if we keep going until we reach the element where there are 8 electrons in this second level, then the second level will be full. And then for the atom after that, the electron would go up to the higher level, which would now be not full again. So coming back to this example, okay, let's say we have lithium. Okay, let's say we have lithium. Let me take this for example. In lithium, imagine that this atom in which the lowest level is full and the next level up is not full. Okay, imagine that we take these atoms and put lots of them together to form a solid. So think of the lithium solid, in other words. Then when you form the lithium solid, the energy levels of lithium will form all these bands. So that's one band, two, another band, another band, another band, and so on. So lots of bands. So each level would become a band, which is basically the combination of all the levels in all the atoms. Okay, so this band here is not a separate band from that band. They're just the same band that runs, that is common for the whole solid. Okay, so for each lithium atom, as we've seen, the lowest level is already full, as in there are 2 electrons there already. So when the lowest level forms the band, okay, that band would be full, because basically the number of levels in the band is just the number of atoms, more or less. Yeah, exactly, in fact. So if the original levels in each atom are already full, then when they form the band would also be full. Okay, so the full level in the helium atom will form a full band when it is together with many other helium atoms in a solid. And the next band up, this second level, for the helium atom is not full, right? Because it can take up to 8 electrons. So when it forms a band, that band is not full. You can imagine that each energy level in that band can also take up to 8 electrons. Alright, the difference between a band and a single level is simply that there are many levels close together. It's like you take all the levels from all the atoms, okay, and rearrange them so that all the energy levels in all the atoms have slightly different energies, and they're all very close together so that it forms a band. So if the original level is not full, the band would not be full. And so now we are ready to come back to look at this statement. A solid is an insulator if all the occupied bands are full. Now, okay, maybe I'll talk. I've talked about how a band can be full or not full with this lithium example. So in the lithium example, the first band is full because the first level of each atom is full, and the second band is not full because the second level of each individual atom is full. It is not full. So there's a simple way to tell whether that band is full. So we kind of understand this part about the band and the full, okay, from the lithium example. And let me just look at the word occupied a bit. What do I mean by occupied bands? So using the lithium example again, the first level corresponds to the first band, second level corresponds to the second band. Okay, so that is the first band, the second band, and the third level gives the third band. Now there are no electrons in the third band, in the third level of the lithium atom. So when the third level forms the third band with all the other atoms, that third band is not occupied in the sense that there are no electrons in the third band. So this is not an occupied band, but those two bands are occupied in the sense that they're occupied by electrons. So that's what occupied means. It just means that there are electrons in that band. So in this condition, it just means that we could just ignore the unoccupied bands. Like for the case of lithium, we can ignore all those and just look at those two that are occupied. And then we have to look at them and think, are these bands fully occupied? So in the case of lithium, the first band is fully occupied, but the second band is not. So this means that one of the there are two occupied bands, but one of them is not fully occupied. So that does not satisfy this condition, which requires that all occupied bands are full for an insulator. So therefore, lithium is not an insulator. Therefore, it can conduct electricity. Now let's look at helium. Now helium is a gas, but in fact, it's extremely difficult to get helium to freeze into a solid. Right? It's almost impossible unless you apply a very, very high pressure, maybe more than 30 times the atmospheric pressure, and cool it down to almost 0 Kelvin. Okay, so we shan't worry about the details, but suppose that I can somehow freeze helium into a solid. Right. If I do that, now you look at helium, the lowest level is full. It has 2 electrons, it's full. The next level up is empty, there's nothing there. So if helium forms a solid, okay, each level would form a band with the levels from other atoms. And because the lowest level is full, but it forms the band, the lowest band would be full, as in fully occupied by electrons. Next level up will be completely empty because it comes from the second level, which has no electrons. So the band that is formed from the second level would be empty. So helium solid, if it exists, is an insulator because all the occupied bands are full. So that's how we can understand this statement. Okay, it's a bit abstract when you see it for the first time, but you have to relate it to the context of the individual atoms and to the bands. Now, for this topic in A-level physics, we don't actually have to know how the levels for each atom for a particular element look like. Most of the time, we would just be looking at examples or schematic diagrams of the band structure itself and trying to figure out, say in exam questions, whether or not a band is full or not full. Alright, this data should be given or hinted at in the exam in some way.